TU100, My Digital Life, Sense and...
Oi! Come out with my title!
In the next exercise, we're going to put together several if blocks in sequence, one after the other. So this programming exercise is going to make use of the sense board again. If it isn't already, plug it into your computer with the USB cable. Open Project 18 and resave it with the _SOL extension. So again, in this exercise your work will be associated with the stage, and we'll be using the following components: the 6 LEDs, the slider and the microphone. And this sends decimal numbers from 0.0 silent through to 100.0 very loud into the sense environment, depending on the ambient noise level as well. Many audio systems, such as hi-fis, use a so-called VU meter display to give some indication of volume. VU meters consist of a number of LEDs. The louder the volume, the more LEDs are illuminated. In this exercise you're going to use Sense and the Sense board to model a VU meter display. The project you've just opened contains a partially completed program. The intention is that the completed program should read sound levels from the Sense board's microphone. When there's no sound, none of the LEDs should be lit, and when there's maximum sound, all of them should be on. Well, actually they'll blink very quickly because, as you'll see, they'll be repeatedly turned on and off. Levels in between these two extremes should be shown by varying the numbers of lit LEDs. It uses one variable called sound reading. Below the green flag block is a forever block. In the jaws of the forever block there's a set sound reading block followed by a wait block. The wait block instructs Sense to wait, in other words suspend execution, for the specified number of seconds before continuing with the next block. Its role in this program is to slow down the blinking of the LEDs, making them easier to observe. To begin with, you'll set your sound reading to the current slider value, so go to Inputs and drag the sensor value block to a clear space in your scripting pane. Use the block's drop-down menu to select slider. Then use the resulting block to replace the input value of 0 in the block set sound reading. Run your program and experiment with moving the slider up and down. The variable watcher should show the value of sound reading changing from 0 through to 100 and back again. Now we want to change the program so that each time the slider value is obtained, the program should first switch off all the LEDs, effectively resetting those that might have been switched on, and check the value of sound reading against the numbers 15, 30, 45, 60, 75 and 90 in turn. Levels should be shown by varying the numbers of lit LEDs as shown in this table. Although your program is ultimately going to monitor sound levels via the sense board's microphone, to begin with, as in the previous exercise, it will instead monitor the position of the sense board's slider because it's easier to obtain particular values using the slider than it is by varying the ambient sound level. Drag an LED block from the Outputs palette and place it directly below the Set Sound Reading to Slider Sensor Value block in the jaws of the Forever block. Set the input values of this LED block so that when executed it turns off all the LEDs. We now need a series of if blocks to carry out the actions described in the table. Each if block should switch on an appropriate LED if its condition is true, using an LED block. So the first if block will decide if sound reading is greater than 15, LED 1 will be switched on. The second if block will decide if sound reading is greater than 30, and if so, LED 2 will be switched on, and so on. Save your project and run the program. Move the slider slowly up and down, observing the value of the sound reading variable watcher on the stage and the LEDs on the sense board. If your program is working correctly, the number of LEDs blinking on the sense board should change correctly as you move the slider to and fro. Click on the stop button when you want to stop your program. Now we've got the program working correctly, we can change the slider sensor value to the sound sensor value in the block. This will evaluate to the sound level value from the sense board's microphone. Save the project again, run the program, then put a source of noise such as a radio or phone near the sense board, move the phone further away and back towards the microphone, or turn up the volume and turn it down, or try simply clapping your hands, shouting, whistling at it. And again, observe the value of the sound reading variable watcher on the stage and the LEDs on the sense board. So you can see that if we slow the program down, the program runs the blocks inside the Forever Blocks jaws, and they're executed repeatedly from top to bottom. Each time the following steps are carried out. The value from the sense board's microphone is obtained, all the LEDs are switched off, the sound value is compared in turn to 15, 30, 45 and so on. If it's greater than 15, LED 1 is turned on. If it's also greater than 30, LED 2 is turned on. If it's also greater than 45, then LED 3 is turned on too. And if it's greater than 60, LED 4 is turned on, and 75, LED 5 is turned on, and if it's also greater than 90, then LED 6 is also turned on. Finally, execution is suspended for 0.1 of a second before the loop begins again. That's all for now in this video, and I'll see you in the next one. Bye for now.